In this video, we'll be looking at quadratics. So, a quadratic is a curve which has the general formula y equals ax squared plus bx plus c, where a, b and c can be any number. So one thing you can do with quadratics is that you can complete the square. For example, if we had y equals x squared plus ax plus 3, we can put this in the form where we have, as shown in binomial, this is multiplied by 2 and times by x. So you can halve it and then square it. But however, there is one thing missing. This is the same as this. However, there is actually another 16. So what we can do is just minus 4 squared plus 3. So y equals x plus 4 squared minus 13. And this is actually a translation as well of the graph of x squared by the vector minus 4, so 4 to the left, and minus 13, and 13 down. The shape of a quadratic is parabolic, which has that shape. Also, the equation for a quadratic in order to find x is minus b plus or minus the square root of b squared minus 4ac all over 2a. And this can be found using the completing the square method. So we can just take the general form where it's ax squared plus bx plus c. We can just take a out of the equation. And we can say this equals to 0 if we want to find x. So what we want to do then is to start completing the square itself. So that's x plus b over 2a squared minus, and then this is minus this unit squared, so b squared over 4a squared plus c over a, which equals 0. And then what we want to do is put them together. Sorry if my handwriting's not great. So it's minus b squared plus 4ac, and this is all over 4a squared, so that equals 0. So what we can do here is actually put the a back, and yeah, the a goes here, okay, and so you can cancel these a's because there's going to be minuses here and things. Hopefully you can follow along. Alright, okay, so when you square root this, that's plus or minus the square root of b squared minus 4ac, and these are both square terms, so there's actually over 2a, as you may be able to see. So x is minus b over 2a plus or minus square root of b squared minus 4ac over 2a, and then we can just combine them. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. Fantastic. One feature of quadratic equations, or quadratics in general, is that there is the discriminant here, and then this determines if the x has real roots or not. For example, if minus 4ac is bigger than b squared, then it's going to be the square root of a negative number, and that is impossible. So we can use the discriminant. We don't need the square root, and that can be used to determine if there are real x solutions. So if the discriminant is greater than 0, then that means the quadratic passes through 2 points, or at least 2 solutions. If it equals 0, then the quadratic is tangential to the x-axis and only touches it at one point. And if the discriminant is less than 0, as I've just established, then it has no real solutions and it does not cross the x-axis.